Guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to identify misleading graphs. That's the key part of today's learning objective. And we also want to explain why these graphs are misleading. So the first thing we're going to do is we're going to chat through, well, what are the characteristics of a good graph? So 5 things a good graph should have. If it has these 5 things, it's typically accepted as a good graph. If it doesn't have these, and you'll be surprised how many graphs don't meet this criteria, then it's not a good graph. So firstly, a graph should have a good title, so the users of the graph know exactly what the graph is trying to achieve, what its topic is. Number 2, it should have clearly labeled axes. The user of the information should know, well, you've got these numbers, you've got these variables, what do they actually represent? And ideally, just writing it down now, they should have some kind of reference to units like centimeters, dollars, time, whatever it might have been. Number 3, this is a common issue with graphs. A good graph, it should be simple. So it should have simplicity. And another way of saying that, it shouldn't really have any distractions. So a lot of graphs are going to have distractions, and they deter from users actually reading the information. Number 4, this relates a little bit to simplicity, but you should have clear data points. And that's another way of saying it should be really easy, it should be readable. That means the users of the graph should be able to get the information out without it being too cryptic. And the very final one, and this is the most common way people manipulate graphs, is they should have uninterrupted axes. And what that means is your x and your y axes, it should start from 0 and then go onwards. We shouldn't randomly start at another number. So to highlight this last point, because it is important, it is, I think, the most prominent way people make their graphs a bit misleading. I've got a graph up here, and we've got the red line and the blue line, and this graph, it's giving me the impression, if you have a look at the top here, if it's giving me the impression that at one point in time, the red line was significantly bigger than the blue line. Absolutely huge amounts. It's been dwarfed by the red line. However, in reality, this is what the graph should have looked like. We can see the gap that I've identified before, it actually isn't that big. It's maybe a 20% different, certainly not as big as this dramatic increase it was. And the reason these graphs, even though they're the exact same, they tell very different stories. The reason the stories are different is the graph on the bottom, as I said, it starts at 0 and it goes up continuously. There's no gaps. The scale is very even and fair. However, this graph, it starts at 75. So it misses out the idea that from 0 to 75, there's no real difference, and that it makes it a bit misleading. So it makes the proportion, that 20% proportion, it makes it look like, well, the entire graph instead of a small chunk of it. At this point here, I've got 2 other graphs just for us to look at, just to chat about how misleading they are. And the first one here, this is a political graph, and you'll find graphs from most political parties will have some kind of twist on it. They want you to think they're better at this, so you should vote for them, when it's the case, it's probably not too much of a difference. So this graph here, it relates to the percentage of people who is agreeing, I'm assuming, with the Supreme Court of the United States, and it's got Democrats, Republicans, and Independents. And what this graph, it's trying to get you to think that, well, look how big this gap is. It's trying to get you to think that the court is making decisions that are in line with the views of the Democrats. That's why the Democrats actually agree with it. And it looks like it's such a significant, huge problem. But if you look at the numbers, our axes are starting at 50. So this gap here, the difference between 50 and 54 is 8%. So 8% is not a significant difference. So it's still saying the majority of Republicans agree with the courts and a majority of the Democrats agree with the courts, but there's only a slight difference. So the picture that it's going to paint, that the Democrats are hugely favoring the court compared with the Republicans, is not actually the case because there's only a small 8% difference. The next graph I've got here, this one is the average female height per country. And you can see the countries. We've got Latvia, Australia, Scotland, Peru, South Africa, India. And what this graph does, it makes me think, well, the people from Latvia, geez, they are so tall. And perhaps the people from India down here, well, they look really, really small. Maybe they're really tiny people. But in reality, the same thing is happening. Our axis does not start at 0. So people from India are on average about 5 foot tall. People on Latvia are on average 5 feet 5 inches tall. So that's quite a small difference. 5 inches, that's like half of from your nose to your forehead type length. So that's not a big difference between people. However, the diagram itself is trying to paint the picture due to the diagrams that people from Latvia are huge, whereas people from India are very small. And the data just does not represent that as well. The other issue with this one, in addition to the axes, probably the simplicity thing here. These big pictures are certainly misleading. They could have just had bar graphs with equal width. However, they've distracted us. The width of the characters making us think that perhaps Latvians are wider as well as taller. So that wraps up our video. We've chatted about the characteristics of misleading graphs, and I've tried to highlight why some graphs are misleading. Hopefully you found it useful. Now let's look into some questions. Let's get into heaps of practice.